All right, so for this one, we're going to go through problem set 2. And what problem set 2 was, it was dealing with functions and finding out the slope formula for the functions. So the first one says, consider the function f of x, that is that 4-term polynomial, write down f of 0, so that represents 0 as the variable. So all I do is I rewrite this equation. Anywhere that x shows up, I input 0. And the good thing about substituting 0 is each term becomes 0 that has x, because 0 cubed is 0, 3 times 0 squared is 0, 24 times 0 is 0, leaves us with just 30. So what does that mean? F of 0 is equal to 30? Well, that means that we have a point. 0 and 30 would be a point on our graph. Next, it says find f dashed x. So that's the derivative of the original function. So remember, what we do is we take the exponent, in this case 3. I'm going to multiply the number out front. So 3 times 1 is 3. Variable stays and we lose one of the exponents. So it was 3, now it becomes 2. Second one, we have 3 out front and 2 is the exponent. So we multiply those for 6. X, and we lose one of the exponents. So that was 2, becomes 1. Next one, we have 1 as the exponent and 24 out front. So 1 times 24 is 24. We lose one of the exponents, becomes x to the power of 0. So that means there's no x's there. And the last term, 30, really, that means that it has no exponent. So it's really like 30x0. So it would multiply 30 times 0, which becomes 0, and that whole term is gone. So any constant is never going to be part of the slope formula. So that's our f dashed x, that's our derivative. Next says find the slope or gradient of the graph where x is equal to 1. So that's saying take our function and input 1. All right, we're going to use our slope function in this case. So I want to know what's the slope when x is equal to 1. So we input these values, and we end up getting negative 27. So that means at that value of 1, our slope is pretty negative because it's negative 27. It's falling to the right pretty steeply too. Let's keep going along. Second one says consider this function. F of x is equal to 3x squared plus 48x. Last section we learned that when I have an exponent or a variable on the bottom that has an exponent, that's the equivalent of having a negative, that exponent. So in this case, because it's on the bottom, will be negative 1. So f of 2 just means take our equation, input 2 into it. So 2 cubed plus 48, 2 to the power of negative 1, or 48 over 2, we could have it that way as well, which will be equal to 8 plus 24, which is 32. So that means this equation has the point 2 and 32. Because when we inputted 2 for x, we got a y value of 32 or an output of 32. F dashed x, that's just the derivative formula. So what I'm going to do is I'm going to look up at the formula up here, and I'm going to multiply the exponents by the number out front. So 3 times 1 is 3x, and we lose one of the exponents. For the next one, we have negative 1 times 48, which would be negative 48. And we lose one of the exponents. It goes from x, negative 1 to negative 2. And then lastly, what we're going to do is we're going to find out the slope when x is equal to 2. That's what this is saying. Use your slope formula, find out the slope when x is equal to 2. So I'm going to find out f dash 2 is equal to 3 times 2 squared minus 48 times 2 to the negative 2. We can put those into our calculator. We're going to get 12 minus 12, which is equal to 0. So that means at an x value of 2, we have a slope of 0, which means, well, it's going to be a flat line. So it must either be a maximum for our graph or a minimum for our graph. Both would be on that line, have a slope of 0 at the maximum or minimum. We kind of talked about that in the last section. That's going to be an important one in the coming weeks. And next one says, find the slope of the tangent to the graph at x is equal to 1. So this is the slope. I want to know when x is equal to 1. So I'm going to put that into the original function that we have for our slope. So 3 times 1 squared minus 48 times 1 to the negative 2. And we solve these ones through. We get 3 take away 48, which is negative 45. So very steep at that spot at negative 1. or sorry, we're a positive 1 for x. Keep going along here. Next one says, find the function as defined by this, find the derivative of it, f prime of x. So before we do that, what I'm going to do is I'm going to write it out in terms of 5x plus 4 plus 6x to the power of negative 1, because the denominator is on the bottom being x, which results in an exponent of negative 1. So now what I'm going to do is I'm going to multiply, go through each of the terms, multiply the exponent by the number out front, the coefficient, which is 1.5. The x value has a 1, so when I lose 1, it becomes 0. So I don't have x to the power of 0, I could put, I guess. For the next one, 4, that's a constant term. That's not going to be part of it, because really, we talked about that earlier, which really means like 4x to the power of 0 currently. And when I multiply 0 times 4, it becomes 0. Anything times 0 becomes 0. So any constant is not going to be part of the derivative. So any derivative of a constant number is 0. And then the last one we have, negative 1 times 6 is negative 6. X to the power of negative 2, because we lose one of the exponents. Subtract 1 from it. Next, find the slope of the function at negative 1. So same idea as above. Input negative 1 to the power of 2. In this case, we're going to get negative 4.5 when we put those into our calculator. So it's going to be a negative slope falling to the right, not as steeply as the other ones, but still negative 4.5 of the slope falling to the right. Justify your answer in part, or to decide whether the function f of x is increasing or decreasing. So we know it's decreasing, just mentioned that. Why is it decreasing? Because slope is negative. Right, we know it's negative 4.5, but that's the idea behind it. Keep going along. Differentiate or take the derivative of this function here. So if I was to write it in normal terms, it would be 3x plus 12 to the power of, or plus 12x to the power of negative 2, because that 2 is on the bottom, changes signs when it comes up. So if I'm taking the derivative, well, first one has exponent of 1, so 1 times 3 is 3, and I lose my exponent, so it becomes x to the power of 0, so none. Second term, negative 2 times 12 is negative 24. X, and we lose an exponent, becomes negative 3. So next one says use that. Maybe I should put the notation here. Use that slope formula or gradient formula that we have to find out when x is equal to 1. So I'm going to solve this where x is equal to 1. So we're going to have 3 minus 24, 1 to the power of negative 3. Well, 1 to the power of negative 3 is still going to be 1. So when I subtract those, put in my calculator, I get a slope of negative 21. Next one, same idea. Use your answer to justify whether it's increasing or decreasing. Decreasing because the slope is negative. Because f prime of 1 is equal to a negative value. It's negative 21, which means it's really steep, but the negative tells me it's decreasing. It's falling to the right. And finally, solve the equation where that derivative, f of x, the one that's at the very top of the screen, is equal to 0. So I'm going to put in 0 in place of f of x. So we have f dashed x here, so I'm going to put 0 in its spot. 0 is equal to 3 minus 24 over x to the power of 3, if we think of it that way. And we're going to isolate for x. We'll bring 3 over to the other side. And when we do so, we'll have that. Then I'm going to multiply both sides by x cubed. We're going to have negative 3x cubed is equal to negative 24. And we're just solving for x. Divide both sides by negative 3. We're going to get x cubed is equal to 8. And then I'm going to cube root both sides, not square root, because it's not square, it's a cube, so we're going to cube root. And when I do that in my calculator, we're going to get x is equal to 2. So that means 2 spots to the right is where the slope will be 0. So that'll be either the top of the mountain or bottom of the hill in a case like that. So for 5, it says the function f of x is given by this following formula. Evaluate f of 1. And we know that means insert 1 wherever x is in our formula. Like so. And then we just use our calculator, we solve it through, and we're going to find out f of 1 is equal to 3. So that means we have a point 1 and 3 on our graph. Next says calculate the derivative of x, or of f of x. So I'm going to take the exponent, so from the original equation, take the exponent multiplied by the number out front, 6x, and lose one of the exponents. Negative 5 times 2 is negative 10, x plus 7. So that's our derivative. If we want to know what is our derivative evaluated at 2, that's just saying what is the slope of our equation, of our function, when x is equal to 2. So I'm going to substitute 2 into our equation. Then we can take out our calculator and solve it. We're going to get 24, take away 20, plus 7 is equal to 11. So that's a positive slope, so it's going up to the right pretty steeply. Question 6 says, consider the function here, find the derivative. So same idea as the one above, just one small difference. So when we're finding the derivative, the only difference is that number on the end. So does anything change when I'm putting in f of 2? No, we know how to do that. And I want to talk about how these two compare to each other. They're different equations. But we'd have 24 minus 20 plus 3, which is 7. So that would also be a positive slope. It wouldn't be as steep as the first one. It'd be a little bit more flat because the first one was 11, and this one was 7. So the second one would be a little bit less steep, but they're both rising to the right. And that's it for 6. We'll go down to 7 here. And here it says find out the derivative f prime of x is equal to 0.5 times 3, which is 1.5 x, and we lose one of the exponents. Negative 2 times 2, which is negative 4 x, and then we have a constant. We know that the constants don't apply to the derivative. So that's our derivative there. Let's find the equation of the tangent line to the curve f at point 1 and 1.5. So what does that mean? Well, we could have some function. We'll end up looking something like this. And 1 and 1.5 would be, somewhere around here. So I want to know the slope of that tangent line. So I can imagine it'd probably be something like this. And the way that I'm going to get the slope of that tangent line, that purple line, is saying, well, I'm looking for f. So I'm using the slope formula, but I want to know what it is when x is equal to 1, because that's what we have over here. So I'm going to input 1 into that equation. Minus 4 times 1. And when I solve that, f dashed of 1 is equal to negative 2.5. So that means the slope of this line is equal to negative 2.5. Right, and it's falling to the right, and that's good. And we'll show that in the graph here in a second. If I actually go over to Desmos and I graph the original equation and that point, it will end up looking something like this, where the blue dot is that point 1 and 1.5. So you can imagine that that line will be falling from the right. So we should have a negative slope at that spot. Next, I want to know what's the y-intercept. So let's go back. I know that the equation of that purple line is y is equal to mx plus b. I know the slope of that line is negative 2.5. And what I'm going to do is use that point that we know is on the line. We know that 1 and 1.5 is on that line. So I'm going to use that for my x and y values. I'm going to plug in 1 for x and 1.5 for y. X should be 1 because x was 1. And I'm going to solve that one through. So 1 times negative 2.5 is negative 2.5. I'm going to bring 2.5 over to the other side. So 1.5 plus 2.5 is equal to b. And when I add those ones together, I get 4. So I know the equation of that tangent line is negative 2.5x plus 4. So if I go back to Desmos and I plug in negative 2.5x plus 4, you should see a line that gets close to that point and follows the tangent line to that point. So y is equal to, we said negative 2.5x plus 4. And you can see that this is the tangent line at that point. Notice that it's always, the green line is always above that line. In this case, the tangent line happens to be above. And that's the equation of that tangent line at the point 1 and 1.5. So that's the idea with that one. Kind of look at some more here. So this one says, gives us a function. It says find out f of x. So we'll do the same idea. F dashed x. So multiply 6 squared minus 10x plus 3. I want to know what's the slope at 2. So f prime 2. Once we input it, and we solve it through 24 minus 20 plus 3, we get a slope of 7. So we have some function, whatever it looks like, but I know that when x is 2, the slope will be 7. So find the equation of the tangent line at that curve. So I'm not going to graph it out just yet, just to see what it looks like, because we don't need to know what the graph looks like. I just know that the slope when x is equal to 2 is 7. So this one says, tell me what is the equation of the line when, our equation of the tangent to the line at point 2 and 3. Well, I know the slope of that point is going to be 7. So I know that the equation of our line is going to be y is equal to 7x plus b. Well, I have an x and I have a y. I'm going to substitute those ones in. 3 is equal to 7 times 2 plus b. 3 is equal to 14 plus b. And when 14 comes over the other side, we're subtracting 14 from 3. We end up with negative 11 is equal to b. So therefore, the equation of the line is equal to 7x minus 11. Right, we just get the slope. That's our m value. And once we have that, we can use the point on the curve 2 and 3 in order to find out our tangent line. And that's it.